Welcome to Naming Covalent Compounds. Today we're going to talk about how to name covalent compounds. And if you remember, covalent compounds are different than the ionic compounds we learned to name last week. Because covalent compounds are made up of nonmetals only. And because they're made up of nonmetals, they are sharing electrons between the atoms. Because of this, that means that we do not have any ions. So where we were naming the ions to name our ionic compounds, we can't name ions that don't exist in the covalent compounds. That means we have to use a different naming system. And in naming covalent compounds, we use Greek prefixes. The Greek prefixes are used to tell us what the subscripts are. So if we have a Greek prefix of mono, that means our subscript is 1. If we have a Greek prefix of di, our subscript is 2. Tri, subscript is 3. Tetra, subscript is 4. Penta, our subscript is 5. Hexa, we have a subscript of 6. Hepta, we have a subscript of 7. Octa, we have a subscript of 8. Nona, we have a subscript of 9. And deca, we have a subscript of 10. Now, for the most part, you would be familiar with these just from everyday language. However, some of the weird ones are, and you do have to memorize these, are tetra. And tetra, to help you remember that, is everybody's favorite video game of Tetris. If we remember, in Tetris, we have blocks, and each block is made up of smaller pieces. And when you look at these smaller pieces, you realize how many blocks they are made up of. And our last one is the hardest one to draw. And if we count, each of these is made up of 4 pieces because this prefix here means 4. So each Tetris piece is made up of 4 blocks. And that's how I remember that 4 is tetra. Deca is 10. 10 years equals 1 decade. And like I said, pretty much the most of them are pretty easy to remember. So now how do we use these Greek prefixes? Well, as I said before, the prefixes tell you the subscript. So in going from formula to name, that's how we're going to start. I'll show you how to use it. So here we have 2 elements, phosphorus and oxygen. So phosphorus, and if you guys didn't think my handwriting could get any worse, I went to a computer and made it worse. And 10, or oxygen, sorry, that's oxygen, right? Right? Well, we have to change it to oxide because just like in our ionic naming, the second part of it gets changed to ide. So the second element, you need to change the ending to IDE. Okay, so that's going to be oxide. So, but prefixes go before the word. Before the element in the name. So, the prefix here is going to be our 4, so that means that's going to be tetra. It's just like we learned before, tetra means 4. It's going to be tetraphosphorus. And 10 is our second one, so put a space. And 10 we said was deca, so deca oxide. So P4O10 is called tetraphosphorus decaoxide. For a second example, let's try this one. Well, I'm going to start with our prefix, our first prefix. So the subscript for the first element is 2. And 2, we learned, was di. So that makes it di. The element here is nitrogen, so we have 2 nitrogen, so it's di-nitrogen. And our second subscript is 4. So that means the prefix for the second element is going to be tetra. And our second element, H, is hydrogen. But remember, the second element, we need to change the ending to "ide." So we're going to take off the ogen and change that to IDE. So that becomes tetrahydride. So N2H4 is dinitrogen tetrahydride. I'm going to try this one in your groups. Okay. My guess is that most of you in your groups came up with this. Monosulfur hexafluoride. Okay. And given what I've told you, that would be correct. However, there is a little intricacy here that if mono is with the first element, and that's what this is, we don't include it. So this is actually sulfur hexafluoride. We do not write the mono. Get rid of that. Okay, so it's just sulfur hexafluoride is our answer. And that is only on the first element. On the second element, we have to have mono. So if I'm going to add another example here, CO, well, we have 1 carbon, so it would be monocarbon, right? But no, because it's on the first element. So that is just carbon. Now the second element is oxygen, so it would be oxide. But because it's a second element, we have to include the mono, so that is carbon monoxide. So second element, mono is mandatory. First element, we don't include it. Now let's move on to name to formula. So our first example, dinitrogen tetrachloride. Well, our first element is carbon. So the first element is carbon, and carbon is represented by the letter C. Our prefix here is di. So di means 2, so it's C2. Our second element is chlorine, because we changed the ending back to what it belongs to, and then we use Cl to represent that. And the subscript comes from the prefix tetra, which means 4, so it's C2Cl3. 4. Another example, dichlorine monoxide. So our first element is Cl. Notice here the ending, it does not end in IDE. So first element, the ending does not change. So chlorine, again, is Cl. Our prefix is di, which means we have 2 of them. Our second element, oxide, well, when we put that back to its regular ending, it is oxygen. So that is O. And mono, that prefix means 1. So I do not write this because by just writing the symbol, the 1 is implied. So dichlorine monoxide is Cl2O. Okay, in your groups, I want you to try iodine tribromide. Okay, now it's time to check your answers. Let's see. Iodine is I, and we only have 1 of them. Bromide is bromine, and that is Br. And the prefix tri means 3. So it is IBr3. Now you're going to get plenty of practice because your homework is the covalent naming worksheet. And it will be passed out by your substitute in just a minute.